In this video, we're going to go over the row reduction algorithm. This is going to allow us to, in an algorithmic way, get any matrix into its reducer or echelon form. So we start with the leftmost non-zero column. We want to use elementary row operations to create a leading one. And so we want to potentially scale that particular row to get a leading one, or maybe do an interchange to get a leading one, but we want a leading one. And then we can use replacement operations to make all other entries in that column zero. So all of the entries above and below that one, we can use replacement to make into a zero. We next move to the next column to the right and repeat this process. You always want to work your way sort of down the matrix so that you aren't undoing any of the previous kind of steps that you had already done to reduce your matrix. But you can, as long as you're not doing any interchanges with the rows above, you can do interchanges or scalings to get leading one in the next row down and the next column over, and just work your way through. So you're going to finally, just keep going through this process until the matrix is in reducer or echelon form. So let's take a look at an example here. So this matrix here is not in reducer or echelon form. We're going to start with the first column here since it's a non-zero column. And we already have a leading one here. So that's good. So we can proceed to get zeros below it using replacement. So we can do row 2 minus 2 row 1 and row 3 minus row 1. So this gives us the next step of the matrix of the row reduction of 1, 2, negative 1, 1, and then 0. 4 minus 2 times 2 is 4 minus 4, so that's 0. Minus 2 minus negative 2, so that's going to be a minus 2 plus 2 is a 0, and then 2 minus 2 is 0. We then get 1 minus 1 is 0 for our third row. 1 minus 2 is negative 1. 1 minus negative 1 is 2. And then 3 minus 1 is 2. So we have now used replacement operations to make all of the other entries in that column zero. We move to the next column to the right and repeat the process. So we're now going to go to our second column, and we're going to use elementary operations to create a leading one in the second column and the second row. Now this second row as it stands is all zeros. So I want to do an interchange to move that to the bottom. So we're at 1, 2, negative 1, 1, and then 0, negative 1, 2, 2, 0, 0, 0, 0. We can then do a scaling of the second row by negative 1. So I'll write that as negative R2 to get a leading 1 in that row. So 1, 2, negative 1, 1, 0, 1, negative 2, negative 2, and then our row of all zeros. And then what's going to be our last step here is to get a 0 above that next leading one by doing row 1 minus 2 row 2. So we'll get to our reducer echelon form matrix of 1, 0, then negative 1 plus 4 is a 3, and then a 1 plus a 4 is a 5, and then we have a 0, 1, negative 2, and then our row of zeros. So this matrix is now in reduced row echelon form. Our book in section 1.3 goes into how we can use a program called Sage to help with computations. In this class, unless you are told otherwise, which you will have to show the row reduction algorithm, sort of all the steps by hand, sometimes on some homeworks and quizzes and exams. But for the most part, unless you're told otherwise, you're welcome to use Sage or some of the other technological tools we introduce to perform the necessary computations. If you're reading our textbook online, describes exactly what the syntax for Sage should look like, and it also comes embedded with Sage cells at appropriate places. So if you go to section 1.3, you'll see throughout some Sage cells as they explain how Sage works. You'll have the opportunity to type Sage commands directly into the cells and execute them, provided you're connected to the internet. So if you want to use Sage, then I highly recommend you just sort of follow along in the book and sort of learn the syntax and use the built-in cells there. Otherwise, a few other technological tools that we want to show. So one of my favorite linear algebra tools to use is this linear algebra toolkit created by Przemysław Bogacki. I apologize, I'm sure I mispronounced that name, but this is a statistics professor out of Old Dominion University. And I want to show you how that works here. So if we come over to the Linear Algebra Toolkit, if you just Google this, or there is a link on our Blackboard for how to get to this, you could see that it supplies sort of the different modules for doing different operations. So for our purposes, one of my favorites is this transforming a matrix to reduced row echelon form. And so we're going to be using some of these other ones, but for now, we'll just click that. And you can see it lets you put however many columns and rows you want. So let's actually go ahead and do the same example that we just did in by hand. Let's do it using this toolkit. So that is going to be it's a 3 by 4 matrix. So we'll push submit. And then it's going to give us these blank spots. We can fill it in. So the matrix was 1, 2, -1, 1, 2, 4, -2, 2, 1, 1, 1, 3. And we push submit. And what's cool is not only does it give you that final reduced row echelon form matrix, which uh, good for us, it does indeed match exactly what we got earlier by hand, but it also gives you steps using that same kind of algorithm. It might do it in a slightly different way, but the sort of general idea is going to be the same. Actually, kind of looking through, it looks very similar to the specific steps we did. But there's going to be some examples where the algorithm that's built in on this website is going to be slightly different than what you might do by hand. But in any case, this is a really nice tool. You can certainly use it just to get that final reducer echelon form matrix, or if you'd like to sort of see what some of the steps could be, you could look at the steps there. Um, the other thing I wanted to talk about was using graphing calculators, actually. So we can use graphing calculators to do many of the operations that we'd like to do with matrices. So if you find yourself with a graphing calculator, then this is another tool that you're welcome to use. Let me go ahead and show you how that can work. So I've got this online graphing calculator here, and let's put in that same matrix that we've been working with for the other two examples. So the way you put a matrix into a graphing calculator, or at least this graphing calculator, not all of them are exactly the same, but for this one, we want to look for this matrix. So that's the second key. It's in blue, so second, and I'll push this key here, and that'll pull up this matrix menu. And so what I want to do is go ahead and edit one of these matrices. I'll just edit matrix A here. And I want to put in the 3 by 4 matrix that we've been working with. So I do that, and you can see it brings up these spots for me to fill it in. So we'll just go ahead and fill it in. 1, again, I'm just going to do the exact same matrix. 2, -1, 1, 2, 4, -2, 2, 1, 1, 1, 3. Okay, and once that's in there, we can go back to that matrix menu, and you can see now matrix A is a 3 by 4 matrix, the one we just put in. If you go over to math, there's a whole bunch of different things you can do, and we're going to be doing a lot of these things throughout the semester. I'm probably not going to show you every time how to do it on the calculator, but hopefully you can kind of figure it out based on what it says in this list and some of the things we're going to be doing. So I want to get this into reducer echelon form. So I'm just going to scroll down here until I see RREF, and I will push enter. Oh, whoops. I need to actually quit out of this and then do that. So math, go down to RREF, and I want to put the matrix in that we have, that we want to put in reducer echelon form. So I go back to that matrix menu, and here I just, in the names column, push that. Okay, and then run it. And you can see the output is that same matrix that we got both when we did this by hand and when we did this using that online linear algebra toolkit. So a lot of good tools. There's plenty of others, whether you're using Sage or the online toolkit or your graphing calculator or Python or MATLAB. There's a plentiful number of tools that you can use, with technology to work with matrices and reduce matrices. So you're welcome to kind of work with whatever you are comfortable with. Again, our book sort of works through with Sage. I am a big proponent of that online linear algebra toolkit because it's really user friendly and gets the job done. But play around, go online, look up how to do some of these things in your favorite tool. If you're comfortable with Python or want to learn Python or have access to MATLAB or something else, you can certainly play around with some of these other ones.